Now that you have practiced your direct variation and inverse variation separately, we're going to talk about what happens when they are combined or you have joint variations. So all we talk about with combined and joint variation, it just uses both direct and inverse variations at the same time. For a combined formula, you see y equals k times x all divided by z. For joint, you see that y equals k times x times z. So examples of these and how they may be written may be y varies directly with the square of x. There's a nice little typo. So we know that directly means that we're going to use, let me get my pen. We're going to use y equals kx. But if you notice, it's not just kx, we have the square of x. So because we have that vocabulary word in there, that means it's actually going to be y equals kx squared. If you look at the next one, you have y varies inversely with the cube of x. Well, we know inversely means y equals k over x, but because of the word cube, we know that we have to put an exponent on x, and that would be to the third power, because the cube of x means x raised to the third power. So if we go down and look at the next one, and we see z varies jointly with x and y. So jointly means we're going to combine together using multiplication. So we have z equals k times x, y. And that would be your formula. The last one says z varies jointly with x and y and inversely with m. So this is a combined variation because we're using both direct and inverse variation. So let's just deal with the first part of it where it says z varies jointly with x and y. If z varies jointly, then we have z equals k times x and y. And inversely means that I'm going to divide by m. So then I have all over m. If you need to pause the video to take this down and take your notes, do so at this time. So we're going to be solving combined and joint variations. The steps for that are very similar as to what I showed you before. And you would just write your formula based upon the problem. Plug in your first set of known values, solve for k. Write your new equation using k, and then solve for your unknown values that you're looking for. So in the first example, we have z varies directly with x and inversely with y. When x is equal to 6, y is equal to 2, and z is equal to 15. Find z when x is 4 and y is equal to 9. So because we have directly with x and inversely with y, this is a combined variation. So my formula would be z equals directly with x means I'm multiplying, so I have k times x. And inversely with y means I'm dividing by y. Notice I only have one k. Constant variation, you only have the k written down once. So at this point, we'll go ahead and substitute in the 6, the 2, and the 15 for their respective variables. So I have 15 equals k times 6, all divided by 2. And I need to simplify this. So 6 divided by 2 is 3. So 15 equals k times 3. In order to get k by itself, I need to divide by 3. So I have 5 equals k. Now that I know what k is, I can go ahead and solve for z in the second part of our problem. So again, I have the exact same equation, z equals, except that I know 5 is k, x over y. So I'm solving for z. 5 times 4 divided by 9. So z equals 5 times 4 is 20 over 9. And that is simplified. Always have it down to as simplified as possible. Second example is z varies directly with the square of x and inversely with y when x is equal to 2, y is equal to 4, and z is equal to 3. Find z when x is 4 and y is 9. So we know that it varies directly with x, but realize we have the square of x. And then it's inversely with y. So z equals k. Directly means I'm going to multiply it with x, but because of this squared right here, that means I have to have an x squared. And inversely means I'm going to be dividing by y. So at this point, you can go ahead and plug in your known values for x, y, and z and solve for k. So I have 3 equals k times 2 squared divided by 4. So 3 equals k, 2 squared is 4, divided by 4, that gives me 1, so 3 is equal to k. Now that I know k, I'm going to go ahead and plug in my known values and solve for z. So z equals, k is 3, x squared divided by y. So z equals 3, my x is 4 squared, and I have 9 for y. So z equals 4 squared is 16. 16 times 3 is 48. All over 9, and I have to reduce. So I know both of these are divisible by 3. Did I do that right? Yeah. So both of these are divisible by 3. So I would have 16 over 3 as my value for z.